Hello guys, welcome to Ramta Solutions. Welcome to your grade 12 mathematics trigonometry exam prep. So the question paper that we are looking at today is from the KwaZulu Natal province. It was written in September 2024. And before we get into it, let's thank testpapers.co.za for their library of question papers. And as you can see, this question paper was a scanned paper. So yeah, they try their best to give us question papers, right? So let's see. Oh, you see, instruction one is not there. Let me check. Even question one, the instruction page is not there, but it's very important, but it's okay. So as you can see, the instruction page is not there, and even question one is missing, but it's okay. We will go to our trigonometry since that's what we are looking for. So we should be grateful that they tried to get this paper, even though it's not complete, but let's do with what we have. The section that we want is covered. All right, guys. As you can see, this trigonometry starts at question 5. And as you can see, this question is 33 marks. Therefore, it means if we are on the right track, we should spend 33 minutes or less. Spending more than 33 minutes could prove to be a bit lethal, guys. We might struggle to finish the exam on time. So it's important. You should know this. 1 mark, you should spend 1 minute. So every mark corresponds to a minute. Okay. If you see 33 marks, you see 33 minutes. Right. So without any waste of time, let's get into it. 5.1, if tan 58 degrees rather is equal to n, determine the following in terms of n without using a calculator. So if you are watching this video on a mobile device, please try to rotate your screen. Let's see now. Sine 1, they say we must determine, 5.1.1, we must determine sine 58 degrees. All right, no worries. So what we have this thing here. So this is 58 degrees. This is 90 degrees. These two angles are complementary. So it must be 32 degrees. And they said sine tan 58. Tan is opposite over adjacent. Opposite is n, and then adjacent is 1. Now we need to know the hypotenuse. We'll say r equals square root of x squared plus y squared. And what is that? X is 1, and then y is n. All right. So what do we have? We have r equals the square root of 1 plus n squared. So this part here is square root of 1 plus n squared. Okay. Now, they say we must find 5.1.1. They say we must find sine 58. Sine 58, as you can see, it's opposite, which is n over hypotenuse. Hypotenuse is square root of 1 plus n squared. So you need to rationalize the denominator. You can leave it here, but please rationalize the denominator. It will be 1 plus square root of 1 plus n squared multiplied by the denominator divided by itself. Okay, this is when you rationalize the denominator. So what do you have? You have n times square root of 1 plus n squared over 1 plus n squared. All right, this is you rationalizing the denominator. All right, perfect. Now 5.1.2, they say we must determine sine 296. What is this? This is similar. We know 296 is in the fourth quadrant. In the fourth quadrant, we work with 360 degrees. So 360 degrees minus 296 must be 64 degrees, isn't it? It must be 64 degrees. Now, this therefore means we know, by the way, sine in the 360 degrees 360 minus quadrant is negative. So this will be negative sine 64 degrees. All right, this will be negative sine 64 degrees. When we look at that diagram that we drew, we don't have 64, but I see we have 32. 64 is double 32, isn't it? Now think about it, guys. This, I want to show you. Let me change the colors because I want to show you. I want to use blue. So x equals 64. No, man, 32. Right? What is 2x? It'll be 64, isn't it? Good. Now let's answer the question. So this is similar to saying it is negative 2 sine 32 degrees times cos 32 degrees, isn't it? Now let's go check what sine 32 degrees is. I think it was n over square root of n plus 2. It's okay. N, was it? No. Okay, it's 1 over sine 32 is 1 over square root of 1 plus n squared. Okay, it's not n, it's 1 over. So it's 1 over square root of 1 plus n squared. What is cos 32? It is the one that is n over square root of 1 plus n squared. Isn't it? Now what do we have? We have negative 2n over 1 plus n squared. Right? Oh yeah. All right, 5.1.3 says cos 2 degrees. Cos 2. I know we had 52. We can say 60 minus, we had 58. So we can say 60 minus 58. That can work as well, isn't it? Yeah, 50. Yeah, it can work. So we can say we have, let's say cos 2 degrees. We can work with cos 60 degrees minus 58, right? So what is this? This is cos. So because it's a minus, it'll be cos plus. So this is cos 60 degrees, cos 60 degrees, cos 58 degrees plus sine 60 degrees, sine 58 degrees, isn't it? Now, what is cos 60? It is half. What is cos 58? Let's go to the diagram. It is 1 over the square root of 1 plus n squared. Right? It is 1 over the square root of 1 plus n squared. Okay? Now, what is sine 60? It is root 3 over 2. And then what is sine 58? Sine 58 will be opposite over hypotenuse, so it's n over the square root of 1 plus n squared. N over the square root of 1 plus n squared. Okay? All right. Now, this will be 1 times 1 is 1 plus, let me say, n root 3. Oops. I've hurried it. So this is 1 over 2 times 1 plus square root of 2. Yeah, 2 times square root of 1 plus n squared plus root 3 or n root 3 over 2 times the square root of 1 plus n squared. Denominators are the same. You can leave it here, guys. Or you can say denominators are the same. And when they are the same, you can say this is 1 plus n root 3 over 2 over 1 plus, 2 over, no. 1 plus n root 3 all over 2 times square root of 1 plus n squared. Oh boy. Okay. So this is what we can say. Okay. This is what we can say. We can leave it here. It's okay. Even if you had left it here, it was still okay. All right. Perfect. Now 5.2. Remember, we have 33 minutes to finish this question. 5.2, given the following identity, 1 minus cos 2x all over sine 2x is equal to tan x. 5.2.1, prove the identity. Which one is easy to manipulate? Is it the left-hand side or the right-hand side? I think the left-hand side. So we will say the left-hand side is equal to 1 minus cos 2x over sine 2x. Interesting. So with what I am seeing, we will need to manipulate the cos 2x. Remember, one of the equations of the forms is that it is equal to cos square x minus sine square x, or it is equal to 2 cos square x minus 1, or 1 minus 2 sine square x. So let's take the 1 minus 2 sine square x. I think this one is easy to manipulate when it's like that. And the double angle at the bottom, sine 2x, we know it is 2 sine x cos x. Now what is this? This is 1 minus 1, isn't it? 1 minus 1, what is it? It is 0. So we are left with 2 sine square x over 2 sine x cos x. The 2's are cancelling and one of the signs is cancelling. We are left with sine x over cos x. Right? Proceeding, sine x over cos x. That's an identity of tangent. This is tan x, and that is the right hand side. Right? That is the right hand side. Okay. I know, guys, some would prefer to say 1 minus 1 plus 2 sine square x. It's okay if you have written that step. Okay? It's okay if you have written that step. All right, moving on. 5.2.2. Let's see now. Use the identity to determine the value of tan 15 degrees in its simplest form. No calculators may be used. Okay, no worries. When they say no calculators may be used, I want you guys to draw things like this. See what I've done? You draw lines like this and you draw 3 lines in between. 1, 2, 3. Those lines represent 30, 45, and 60 degrees. Okay? And then you start numbering from the top. You say it's 0, 1, 2, 3, 4, and write semicolons. Okay? And then you then start from the bottom. Say 0, 1, 2, 3, 4. Then you put square roots in all of them. Okay? You put square roots in all of them. Okay, you put square roots in all of them. I didn't put the square root in 1 and 0 because it's still 1 and it's still 0. Right? All right. So now this represents x, y, and this is r. Okay, so if they say sine 30, you know sine is y over r. So you will say 30 degrees minus this one. Then you'll say 1 over 2. Sine 30 is half. Okay, so this is a trick that you can use in your exams. Let's proceed. So 5.2.2. Oops, we had started already. I don't know why I'm writing it again. Yes, we had started. So we say tan 15 degrees, it doesn't matter, will be equal to this equation as it is, where there's x, we put 15. 1 minus cos 2 times 15 degrees all over sine 2 times 15 degrees. Okay? So this is 1 minus cos 30 degrees all over sine 30 degrees. Now what is cos 30 degrees? It is root 3 over 2. What is sine 30 degrees? It is half. You can go check it out in the diagram. Cos 30 is root 3, which is x over r. Okay, perfect. Now, what we know, because we're not using a calculator, we know we have to simplify this. So this will be 2 minus root 3. All right, 2 minus root 3 over 2, all divided by half. Therefore, your answer will be 2 minus root 3. If you're wondering how we got there, it's like this. 2 minus root 3 all over 2 divided by half. And then you know this will be 2 minus root 3 all over 2 multiplied by 2 over 1. Hence, you are getting this answer here. Okay, perfect. 5.3, let's see, 5.3 says, woo, simplify to a single trigonometric ratio. So here we have sine 360 degrees. Remember, guys, if you're using a mobile device, to please rotate your screen so you have improved view. Okay, and then minus sine x over cos open bracket negative x close times tan open bracket 360 degrees minus x close. Sine in the 360 degrees plus is, where is that quadrant? This is the first quadrant, so it is positive, so it will be positive sine. Now cosine in the 90 plus quadrant, in the 90 degrees plus quadrant, which one is that? It is the second quadrant. It is negative, but because of the 90, cosine will change, it will become sine x minus sine x. Negative angle of cosine will be positive cos x. Tangent in the 360 degrees minus, which quadrant is that? It is the fourth quadrant, so it is negative, right? It is negative, right? It is negative. Okay, now negative times negative will be, sorry, positive times negative is negative, so this is negative sine square x. There's a negative here, divided by this one, it'll be positive. We have positive sine x over cos x. Now this tangent, I'm going to change it. We know its identity, it's sine x over cos x, isn't it? It is, now it is sine x over cos x. Now we know this is 1 minus sine square x, right? Minus sine square x, and this cos x cancels with cos x, sine x cancels with sine x. We are left with positive 1. Now this looks like we have cos square x. Okay, this looks like we have cos square x. Okay, we have cos square x. This is a single trigonometric ratio, so we are good. Now let's see 5.4, the general solution. Let's see, cos 2x minus 1 over 3 is equal to 1 over 3 sine x. Let's multiply by 3 throughout. It'll be 3 cos 2x minus 1, minus 1 equals sine x. As you can see here, we have sine. So this double angle, we will have to change it to make it that of sine. So remember, there are 3 equations of your cosine double angle. So we will choose the one with sine. Then it'll be 3 open bracket 1 minus 2 sine square x close bracket minus 1 equals sine x. Now what do we have? We have 3 minus 6 sine square x minus 1 equals sine x. Therefore, we can say we have 0 equals 6 sine square x plus sine x. This is 2 minus 1. So 3 minus 1, it will be 2, and it will be minus 2. Okay? Now, we have 0 equals, factorize, open, leave a space, sine x minus 2, close, leave a space, sine x minus 1, close. The reason I used negatives so far is because I know it's easy to make it a positive, okay? Now, factors of 2 are 2 and 1, we are good. But we need the factors of 6 to make this equation work. A part of me sees, let me see. Perhaps, uh, let me see. Um, okay, I'm gonna use 3 sine x minus 2, and then but this must be plus 2. Okay, and this must be 2 sine x minus 1. Indeed, it's gonna work because this is negative 3 sine x and this is positive 4 sine x. All right, and this is the one that's working. So we have sine x equals negative 2 over 3, or sine x equals half. Okay, because I'm sharing this screen with the question paper, I'm just going to start with 1. Okay, so let me start with sine x equals negative 2 over 3. Okay, so here we're saying sine x is equal to negative 2 over 3. Now we can see here, we can say the reference angle is sine inverse of 2 over 3. Remember, we ignore the sine. So what is this? Using our calculators, sine inverse of, meaning shift sign, is 2 over 2 over 3. We are getting 41.81. So we are getting 41.81 degrees, right? All right. So as you can see here, tangent is, why am I saying tangent? Sine is equal to negative 2 and 3. So that means we're looking for a region where sine is negative. Where is that? That is the third quadrant. And remember, in the third quadrant, we work with the reduction formula 180 plus the reference angle, right? 180 plus the reference angle plus 360 degrees K, where K is an element of an integer. So this is 221, 221,81 degrees plus 360 degrees K. All right. Now, sine is also positive in the fourth quadrant. In the fourth quadrant, we work with which reduction formula? 360 minus a reference angle, right? 360 minus 41,81 degrees plus 360 degrees K, where K is an element of an integer. 360 minus 41 should be 318.19. Yeah, 318.19 plus 360 degrees K. This is for the first part. The second part was sine x equals half. Right, sine x equals half. Because I don't have enough space, I can work them out like this. But if you have enough space, guys, you can write them one portion here. On the left, it can be sine x equals negative 2 over 3, and the other equals half. Okay? All right. So here, the reference angle is sine inverse of half. What is this? This is 30 degrees. Remember, at this point, you are using a calculator. Oh, yeah, it's 30 degrees. So, where is sine positive? As you can see, sine x is equal to positive half. Sine is positive in the first quadrant. In the first quadrant, we work with the reference angle plus 360 degrees K, where K is an element of an integer. Again, where is sine positive? It is positive in the second quadrant. In the second quadrant, we work with 180 minus the reference angle, right? Plus 360 degrees K, where K is an element of an integer. Now that's 180 minus 30 is 150. You don't need to use a calculator for that. Yeah? Is 150 degrees plus 180 degrees K. Happy? Great. Now let's see 5.5. Ooh, I like this. For which values of k will sine 2x plus 30 degrees, close bracket, plus k equals 3 have no solution? So let's see. We have sine 2x plus 30 degrees plus k equals 3. Then we have sine 2x plus 30 degrees close equals 3 minus k. As you can see here, the coefficient of the trig ratio is 1, meaning its amplitude is 1. The highest value is 1 and the minimum value is -1. So for it to not have a solution, let me just show you. This is your normal sine graph, the maximum being +1 and the minimum being -1, isn't it? So for it to not have a solution, this right hand side must be greater than +1. Okay, so in other words, for it to not have a solution, we must say to not have a solution, I will choose the left hand side. I will sine 2x plus 30 must be greater than 1, or the very same thing must be less than -1. Pardon me. I said plus 30 degrees, right? So what did we say? We said sine 2x plus 30 is equal to 3 minus k. This is the same as 3 minus k. So 3 minus k must be greater than 1. Again, even here, must be less than -1. Okay, so let me just solve them in a way. So this will be negative k is greater than -2. Dividing by negative, k will be less than 2. And here, negative k is less than -4. Therefore, k will be greater than 4. So this is when they do not, or when this equation will not have a solution. If k is less than 2, it will not have a solution. Or if k is greater than 4, it will not have a solution. Okay. All right. Now, check this out. We were done in like 27 minutes and we started at about the third minute. So this means we did this in like 24 minutes or 23, right? That means we are on the right track. So you see, you have saved some time. Good to go. You now have time to focus on other questions that may be difficult. Now let's go to this question 6. Let's see what it says. Question 6. In the diagram below, the graphs of f of x equals tan bx and g of x equals cos x minus 30 degrees are drawn on the same set of axes for x is greater or equal to -180 degrees but less or equal to 180 degrees. The point P with the coordinates 90 degrees and 1 lies on F. So I want to tell you something. When you look at this guy, g of x, it is your normal cosine, but it has shifted 30 degrees to the right. And then you look at your tangent. When you look at this graph, where's the tangent? Here is it. You can see that when you look at the distance between two asymptotes is 360 degrees. Normally, when we look for the period of tangent, we say it is 180 degrees over b. So this, if the period, the way that I'm seeing it, is 360, it means then that the period here is 360 degrees for this tangent. All right, it's 360 degrees. This therefore would mean b should be half, but I'm going to show it differently. So let's see. We are given f of x. Remember I said b is half. F of x is equal to tan bx. We have a point P with coordinates 90 degrees and 1. Where there's x, we put 90 degrees. Where there's y, we put 1. All right. So here is it. Y is 1. and then 90 degrees B. Right? 90 degrees B. Okay. Now moving on, we will say we have um, tan inverse of 1 is equal to 90 degrees B. So what is tan inverse of 1? This is 45, right? This is 45 degrees, and 45 degrees is equal to 90 degrees. When we solve for B, we'll realize that B is half. Okay. So if you didn't understand it the first time, then this is the way to go. Okay. Perfect. 6.2. What is the period of G? The period of G, you don't even have to waste your time. It is 360. As you can see, if you were to put a ruler here, you will see that the points are in phase. Okay, the points are in phase. So it is 360 degrees. Otherwise, or you can say period is 360 degrees over B. What is B? B is the coefficient of X. It is 1. Isn't it? So this is 360 degrees. Okay? Perfect. Now, 6.3. 6.3. Write down the coordinates of A, the turning point of G. So one thing I had told you, or this is one thing you know, with your normal cosine graph, it is like this. So this one is when y is equal to cos x. So this is your 1 at 0 degrees, and this is your -1, and this is your 90. As you can see, the first maximum is at 0 degrees, but now your first maximum has shifted, and now what did we say our graph has shifted with? 30 degrees to the right. So therefore it means A is 30 degrees and 1, because this is the first maximum. Can you see that? So it is 30 degrees and 1. Okay, it is this graph, but it has shifted slightly to the right. All right, perfect. 6.4. Okay, 6.4. Now 6.4, we are then asking ourselves, 6.4, we are then asking ourselves, let's see, write down the equations of the asymptotes of y is equal to, check this one out, y is equal to tan b into x plus 20. So with this one, it says the graph that we had, what was it? It was basically tan, it was g of x, right? But it was g of x shifting 20 degrees to the left. Are you guys hearing me? It is g of x shifting 20 degrees to the left. Okay, g of x shifting 20 degrees to the Okay, so if g of x is shifting 20 degrees to the left, now listen, they say what are the equations of the asymptotes? So if this point shifts 20 degrees to the left, it will be to the left, guys, meaning it's going to the left, okay? It will be minus 180 minus 20, which will be minus 200 degrees. That is not in the domain. This point, if it shifts 20 degrees to the left, it will be 160. Hence, it is only one mark. So it is 160 degrees. So this is me trying to show you what is happening. Okay, so it is x equals 160 degrees. Okay, perfect. Now, 6.5, oh boy, 6.5, determine the range of h if h of x, check this out, h of x is 2 times g of x minus 1. Ask yourself, hold on, what is g of x? G of x is cos x minus 30 degrees minus 1. The maximum, forget the 1 for now, the maximum, okay, the maximum for this guy without the 1 would be positive 2, and the minimum would be negative 2. But now it is going 1 unit down, all right? It is going 1 unit down. So if it was 2 and negative 2, it will then mean y is an element of included. Negative 2 minus 1 will be negative 3. Positive 2 minus 1 will be positive 1. Okay, so this was gonna, oh no, this is the range of this equation. Okay, okay, guys, remember what I said to you. This, it means it's g of x now amplified, right? Its maximum is no longer at 1, but now at 2. And its minimum is at minus 2. But it, and or further, it shifts 1 unit down. When it shifts 1 unit down, it means it's no longer minus 2 to positive 2, but rather minus 3 to positive 1. Okay, perfect. Now, let's see if we have enough space on this page. Okay, we do. Now, question 7. Let's read question 7. Question 7. Okay, buddy, let me remove you here. Question 7. In the diagram, B, C, and D lie in the same horizontal plane. Okay, BD is equal to 2 times CD. Where is it? BD is equal to 2 times CD. So what I'm gathering here is that BD is equal to CD is B. So it means BD is 2B. Okay? BD is 2 small letter b. Angle CBD is x. Where is it? Okay, I can see it. Angle BCD is y. I can see it. And then CD is b. All right. AB is a vertical tower. Okay. The angle of elevation of A from C is theta. I can see you, buddy. 7.1. Show that. So we need 51 minutes to be done with this question. Okay. Show that sine y is equal to 2 sine x. Sine y is equal to 2 sine x. Wait, okay. I see. Sine y. Where is it? Ah, okay, cool. So remember, guys, we know BD and we also know CD. Okay, so what we're going to do is this. We're going to say, they say sine y. So we're going to say sine angle BCD. Sine angle BCD is this one here over, what is the side opposite it? BD is equal to, what is this? Is equal to sine angle CBD, Central Business District, right? It's this one here in this triangle over, what is the side opposite it? CD, right? So this is when we use sine rule. All right. So the angle BCD is sine y, and then BD, what is it? BD, we said it is 2B, and then angle CBD is x, CD is B. Therefore, we can say sine y is equal to 2. Okay, let me just do this. 2B sine x over B. Otherwise, sine y is equal to 2 sine x. Okay, this is not that necessary. But in case you want to understand how I got to my answer, you can include it. Okay, so we done. 7.2, 7.2, prove that AB is equal to B tan theta times the square root of 5 plus 4 cos open bracket x plus y. So here we're going to use cosine rule, and I'm going to say in triangle BDC, okay? In triangle BDC. So I want to say here, I don't know what AB is. No, I don't need AB. I think I need, yeah, let me get this guy first. Let me get BC first, okay? So to get BC, I know what this guy is, right? I know what this guy is, isn't it? So we know that angle D here is 180 degrees minus x minus y. If you like, you can say it is 180 degrees minus, open bracket, x plus y. Is that okay? Perfect. Now, we'll say this is BC squared. I'm using cosine rule. BC squared equals BD squared plus CD squared minus 2 times BD times CD times cos, I'm going to say cos angle D. Okay? Right. I don't know what BC is, so let me just proceed. BC squared. What is BD? BD was 2 times B. What is CD? It is B. This is 2 times 2B times B cos 180 degrees minus X plus Y close close. Again, BC squared is equal to 4B squared plus B squared minus 4B squared. As you can see, this is cos 180 minus. Cos in the 180 minus is negative. Then negative times negative, it will be positive. So it's cos x plus y. Okay? Cos x plus y. Is that okay? So, I should have simplified. Okay, maybe I should now. This is 5b squared plus 4b squared cos x plus y. Okay, so bc will be common factor here is b squared. Maybe let me say that. So it's 5 minus, sorry, 5 plus 4 cos x plus y close close. So BC will be the square root of this. So meaning it'll be square root of this guy will be B times the square root of this guy. 5 plus 4 cos x plus y. Okay, that is BC. However, the question is not asking us to find BC. Okay, the question is not asking us to find BC, but it's rather asking us to find AB. So now we have this side here and we can find this side here. So we have this side to angle theta is adjacent and this is opposite. Adjacent and opposite, it means we must use cosine rule. I mean tangent. Okay, so in triangle ABC, I'm gonna say tan theta equals, hear me out, tan theta equals opposite is AB over what is adjacent? BC. Right. Perfect. Therefore, AB is basically BC, or let me say tan theta times BC. Okay. Now, tan theta, what is BC? BC is B, right, times the square root of 5 plus 4 cos x plus y, right? So this is it. We're done. 37 marks, right? 37 marks. 7.3, 7.3, hence determine the height of, okay. Hence determine the height of the tower, rounded off to 2 decimal places. 3 marks. Rounded off to 2 decimal places if B is 54.8 meters, X is 31 degrees, theta is 42.6 degrees, and Y is 70 what? 75.84 degrees. Okay, we proceed. Therefore, AB is tan, what is theta? 42.6 degrees. What is B? B is 54.8. Theta is 42.6 degrees. And then X is 31 degrees. Y is 75.8. Oops, it looks like 76. 75.84 degrees close. So this one is under a square root. Right? Now let's get our answer. Interesting. 54.8 open, tan 42.6 close, and then square root of 5 plus 4 cos 31 plus 75.84 close. What is our answer? It is 98.76. So it is 98.76 meters. And this is the height of the tower. So check, we were supposed to be done in 51 minutes. We were done in 45. So if we also account for me explaining and stuff, guys, also the introduction, it means you will have saved about 11 minutes. So you have extra 41 minutes now to fix your mistakes. So with that being said, ours ends here. And remember, you can follow us on your favorite social media platforms. The links are given in the description of this video. And if this was helpful and you got to this point, please like and share with your classmates. In addition, please subscribe. And remember, all the best with your examinations. So, bye bye.